Our universe is full of many colorful things that even an entire human life would not be enough to observe them all. So, the questions here are, why do we need to observe them? And what's the meaning of these stunningly beautiful colors in the universe? Unlike humans, universe don't have mouth to communicate with us verbally. It uses pictures and events to tell us its secret stories. Things like stars, galaxies, and massive explosion in the universe radiate bright colorful light with different wavelengths and intensities. And the human eye has very limited visible range of wavelengths between 400 to 700 nanometers, that is between violet and red color. But there are many different radiations which have broader wavelength than the capacity of our eye, like infrared, ultraviolet, and microwaves, etc. And when the distance between a telescope and object increases, visible color range appears to be less and less distinguishable. Hence, images from faraway objects are captured in black and white colors only.
Then how do we get colored images of galaxies which are light years away from us?
The answer to the above question is using editing. Surprised, huh? So, does this mean all the images of space we saw were fake? No! The images were edited to show how human eye will see these objects if we went close enough to distinguish between the visible range of colors.
But how does this complex editing take place?
Editing of such images is not that complex. With enough resources, even we can also edit some black and white images to resemble flashy pictures from NASA. Every color in the visible range can be constructed by using different combinations of three primary colors, which are red, green, and blue. To apply the exact intensity of these colored filters, we should have the wavelengths of radiation from these interstellar objects. And depending on the wavelength, we can find material composition as well as colors emitted from that object. Every element will have its unique set of properties. For example, hydrogen will always emit radiations in the range of infrared color. Similarly, sulfur will emit in the red color range, whereas oxygen will emit in blue radiations. If you want to understand how we determine the material composition of a distant star, you can simply perform a home experiment using LPG gas for cooking at your home. You will find blue colored flame coming out of it. If you don't have LPG at your home, no worries. You can simply use hand sanitizers as well. If you carefully light up the droplets of hand sanitizers, you will get either blue or colorless flames. These colors are based on the contents of hand sanitizers or cooking gas. Now, if you just sprinkled a little bit of table salt on these flames, its colors will change to bright yellow. This happens because table salt contains sodium, and sodium's quantum properties are emitting bright yellow color, which you can also see in older sodium repel lamps used in street lights. Our telescopes are equipped with instruments capable of measuring wavelengths beyond visible spectrum. Based on the wavelengths, we categorize them into three primary colored filters. If we have a mixture of infrared, red, and blue wavelengths, then we will consider the intensity of infrared for red filter, normal red for green filter, and blue for the blue filter. Based on above, we will get the final colored image of the object. And that is how images captured from distant objects are edited. If you find this video cool, please leave a like and subscribe to Science Today. And comment down what you would like to see in the future. Thanks for watching. Bye-bye.